This honors geometry lesson is on section 11.4, the slope of a line, and 11.5, parallel and perpendicular lines. The objectives are to find the slope of a line containing 2 points and to determine whether 2 lines are parallel, perpendicular, or neither. Recall from Algebra 1, the slope refers to the steepness of a line. There are 3 different ways in which you can refer to slope. The first is your change in y over your change in x. Remember that the triangle means change. In a graph, you can refer to slope as the rise over the run. Or, given 2 ordered pairs, you can use your slope formula. So remember, m means slope. So you can take y2 minus y1 divided by x2 minus x1. In example 1, we are going to find the slope of a segment that joins the points -1, 3 and 2, 5. So recall from the previous slide that the slope, which is m, can be found by taking y2 minus y1 over x2 minus x1. So if we fill in our information given our ordered pairs, so we can take 5 minus 3 over 2 minus a -1, and we can simplify to find our slope. So 5 minus 3 is 2. Leave change, so 2 plus 1 is 3. So the slope of the line that contains these 2 ordered pairs is 2, 3. In example 2, we are going to find the slope of the segment that joins points 6, -2 and 3, -2. So our slope can be found by taking -2 minus a -2 divided by 3 minus 6. So if we do leave change, so -2 plus 2 is 0, and 3 minus 6 is -3. 0 over -3 gives us a slope of 0. Recall from Algebra 1 that a slope of 0 refers to a horizontal line. For example 3, we are going to find the slope of the segment that joins points 4, 3 and 4, -5. So our slope can be found by taking -5 minus 3 over 4 minus 4, which simplifies to a -8 over 0. Remember that a 0 in a denominator means that this fraction, or this slope, is undefined. An undefined slope represents a vertical line and these are our 2 special types of slopes. So we actually have 4 different types of slopes. We have a positive slope, which means the graph increases from left to right. We have a negative slope, which means the graph decreases from left to right. And our 2 special cases where we have horizontal lines which carry a slope of 0 and vertical lines which carry an undefined slope. When you look at parallel lines, you can see that the lines have equal slopes. Since the lines do not intersect, they rise and run at the same rate. Theorem 11-4 states that 2 non-vertical lines are parallel if and only if their slopes are equal. Theorem 11-5 states that 2 non-vertical lines are perpendicular if and only if the product of their slopes is -1. So remember, product means to multiply. Also remember that perpendicular lines form 90-degree angles. So if you take the first slope of the line times the second slope of the other line and the product is -1, you have 2 sets of perpendicular lines. So if we have a slope of 1/4 and a slope of -4, if we multiply these, so 1 times -4 is -4, 4 times 1 is 4, which reduces to -1, we can say that a slope of 1/4 and a slope of -4 are perpendicular slopes. If you look at a second example, let's say that we have a slope of -2/5 and a slope of 5/2. If we multiply negative 2/5 times 5/2, we're going to get negative 10 over 10, which reduces to negative 1. So we can say that a slope of negative 2/5 and a slope of 5/2 will give us a slope of two perpendicular lines. Are the two lines with the given slopes parallel, perpendicular, or neither? Let's go ahead and look at example 1. So remember, if we multiply the slopes and they give us a product of negative 1, they're perpendicular. If the slopes are the same, it means that they rise and run at the same rate, which will give us two sets of or a pair of parallel lines. And if they give us neither of those, then they're going to be just a set of intersecting lines. So looking at the first example, we have a slope of 3/4 for the first line. And the second line, if we reduce our slope, we're going to see that 12/16 reduces to 3/4. Since both slopes are the same, these are the slopes of parallel lines. For the second example, we can see that the first slope is 1 and the second slope is negative 1. So we know that the lines are not going to be parallel because the slopes are different. But if we take the first slope times the second slope, we are going to get a product of negative 1, which tells us that these slopes are perpendicular. For our last example, we have a slope of 3 and a slope of negative 3. So again, we can tell that these are not going to be parallel slopes because they are not the same. So we're going to test to see if they are perpendicular. So if we take the first slope of 3 times the second slope of negative 3, we're actually going to get a value of negative 9. So since the product is not negative 1, we know that the lines are not perpendicular. Since the slopes are not the same, we know they are not parallel. Therefore, these lines are neither perpendicular nor parallel, which just means they are a set of intersecting lines that do not intersect at a 90-degree angle. This is the end of the lesson. If you have any questions, feel free to watch the video for a second time. After watching the video, if you still have any questions, write them down and bring them to the next class.